Okay, so let's take a look at Theorem 18. It says if we have the Laplace transform of f of t, say we call that big F of s, and a is any real number, then the Laplace transform of e to the at times my f equals big F of s minus a. Okay, let's start the proof over here. Okay, so the first thing is to recall the definition of Laplace transform. Say Laplace transform of g of t is going to be integral 0 to infinity g of t e to the minus st dt. Okay, now let's look at this guy. Let me write down here. Okay, so now the Laplace transform of e to the at ft. Let's call this whole thing g, so I'm using this definition up here. So it's going to be integral 0 to infinity of my g. So integral 0 to infinity of my g. My g here is e to the at f of t, then e to the minus st. Now we can combine the e terms, so let me do that over here. So I combine the e terms, so it'll be e to the at minus st. I'm going to factor out the t here. So do not, factoring out a t gives us then down here. So it gives us this. And if we compare this to the Laplace transform definition, it looks very similar, except we have an a minus s instead of a minus s. So I'd like to change this to have a minus sign in front. So let's factor a minus sign out of this. So factoring a minus sign out of this guy, we get then we get this, so I factor a minus sign out, so it becomes then minus s minus a. Let's call the s minus a, let's call that s tilde. So I'm going to call the s minus a my s tilde. Then it looks just like the Laplace transform definition, except we have an s tilde in place of an s. So therefore it's going to be big F of s tilde, so it's a Laplace transform of f, but not of s anymore. It'll be of s tilde, because s tilde is s minus a. But then I can replace the s tilde now with s minus a, so this will be then big F of s minus a. So it'll be big F of s minus a, and that's what we're trying to show. So we're done with the theorem. All right, so let's take a look at some examples now. So let me erase this and we'll take a look at some examples. So example, let's evaluate Laplace of e to the 2t, t to the fourth. Let's recall some things here. Okay, so recall from Theorem 14 that the Laplace transform of t to the n is n factorial over s to the n plus 1. So in particular, if you have a Laplace transform of t to the fourth, that's when n is 4. You'd have then 4 factorial over s to the n plus 1. And 4 factorial means 4 times 3 times 2 times 1. So that's 24 if you multiply it out over s to the fifth. So let me write it here. Okay, so 4 factorial again is 24, and it'll be over s to the fifth. So that's what we'll be calling our big F of s here in the Theorem 18 up here. So our a is going to be 2, it looks like. Let's note that. Okay, so our a then is 2, looking at the Theorem 18 up here. So Theorem 18 says it's going to be big F of s minus a, so it's going to be big F of s minus 2 in our case. And the big F they're talking about in our case is the 24 over s to the fifth. So pretty much in place of s, you're going to replace it with s minus 2. So doing that, we get then so replacing s down here with s minus 2, we'll have then 24 over s minus 2 to the fifth. So that'll be our answer. Okay, so we're done with A here. Let's do another example. So let me erase a few things and we'll do part B. Okay, so part B, Laplace, we need to find the Laplace transform of e to the minus 5t cosine 6t. So let's first find Laplace transform of cosine of 6t. So let's recall some things. So recall by theorem 15, the Laplace transform of cosine of kt equals s over s squared plus k squared. So let's now find the Laplace transform of 6t. I write down here. Okay, so Laplace transform of cosine of 6t, so the k would be 6 here. So it'll be s over s squared plus k squared, which is 6 squared. So it'll be s over s squared plus 36. We want to call that our big F of s. Now we're going to look at theorem 18 and apply it here. So let's identify the a. It looks like the a is going to be negative 5 here. Okay, so the a will be negative 5. So according to theorem 18 then, the Laplace of e to the atft will be big F of s minus a, or a here is negative 5, so it's going to be s minus a minus 5. So it'll be big F of s plus 5. My big F is here. So in place of s, I'm going to write s plus 5 over here, and this guy here. So doing that, we get then. Okay, so I just went down to my f, big F of s here. In place of the s, I put s plus 5. In place of the s squared, I put s plus 5 squared plus 36. So this is our answer then, according to theorem 8. So we can box this. Okay, we're done. So I'm going to leave it there in this video, and we'll pick it up with more examples in the next video.